Cipher Nation. This is Coach Cheek walking you through problems involving operations and scientific notation. Over the last couple of days, we've been learning how to add, subtract, multiply, and divide numbers that are expressed in scientific notation. Please remember, every number written in scientific notation has two parts. The first being a factor with a number between 1 and 10. This is called your coefficient. The second factor being a power of 10 with a base of 10 and an exponent. Now let's take a look at how to multiply numbers written in scientific notation. First, you will multiply the coefficients. Using the associative property, we can regroup our coefficients together, and we can regroup our powers of 10 together. Two times 4 gives us 8, and then remembering our rules of exponents and applying our product of powers rule, we can multiply 10 to the third times 10 squared. When you multiply a power times a power, you keep the base and add the exponent. This gives you 8 times 10 to the fifth. Let's take a look at another example. Again, your first step is to multiply the coefficients. When we multiply 6 times 3, we get 18. When we multiply 10 to the second power times 10 to the fifth power, we get 10 to the seventh power. Our third step says to check and see if our product is written in scientific notation. We do this by checking to see if the coefficient is greater than or equal to 1 and less than 10. In this example, 18 does not lie between 1 and 10. We must rewrite to create a number between 1 and 10. We will move the decimal back one place to create 1.8. Since we decreased the size of the coefficient, we now increase the size of our exponent. Since we moved the decimal place back one place value, we will now add 1 power of 10 to get 10 to the 8th. Now our number is written in scientific notation. Example number 3. Again, your first step is to multiply the coefficients. This time, one of the coefficients happens to be a decimal. When we multiply, we get 12 times, multiply our power times our power, 10 to the negative 2. Negative 4 plus 2 gives us negative 2. Step 3. Is our number written in scientific notation? It is not. We must move the decimal back one place to create 1.2. Since we made our coefficient smaller, we now make our exponent bigger by adding 1 to the power of 10 to give us 10 to the negative 1. Our answer is now written in scientific notation. Now let's look at some examples of dividing numbers written in scientific notation. The steps are similar to multiplying. We will first divide our coefficients. Using the associative property, we can regroup our coefficients, and we can regroup our powers of 10. When we divide our coefficients, 8 divided by 2 is equal to 4. Using the quotient of powers rule, 10 to the 7th divided by 10 to the 3rd, we keep the base and subtract the exponents. This should be times. We get a final answer of 4 times 10 to the 4th, written in scientific notation. Here's another example of dividing with numbers written in scientific notation. 6 divided by 8. 8 goes into 6 0 times. We bring down our zeros. 8 goes into 60 7 times, with 4 left over. We bring down a 0. 8 goes into 40 5 times. We now have a remainder of 0 and a decimal of 0.75. Now we divide our powers, and we get 10 to the 3rd divided by 10 to the 8th. We keep the base and subtract the exponents, giving us 10 to the negative 5. We now have 0.75 times 10 to the negative 5. Step 3 asks us to check and see if the quotient is written in scientific notation. It is not. We must move our decimal one place to the right. We are increasing our coefficient, and so our power of 10 will decrease. Our final answer will be 7.5 times 10 to the negative 6. One more example of dividing numbers written in scientific notation. This time we have a decimal in the numerator. 6 will not go into 1. We bring down to 8. 6 will go into 18 3 times. That leaves us with a remainder of 0. We now divide our powers of 10. We keep the base and subtract the exponents, giving us 10 to the negative 6. We now have 0.3 times 10 to the negative 6. We check to see if our number is written in scientific notation by seeing if our coefficient is greater than or equal to 1, but less than 10. It is not. We must move the decimal one place to the right. We now create 3 times 10 to the negative 7. Our next example is adding or subtracting numbers written in scientific notation. We must first create a common exponent. Another way to say that is to create the same power of 10. Looking at the smaller power of 10, we will move the decimal to the left or to the right to match the exponent, or to create the same power of 10. I will move the decimal 2 places to the left, so that I now have 0.025 times 10 to the 7th. Now that our powers are the same, I can add 6 .37 and .025. Step number 4 tells us to keep the same power of 10. And then check to see if my number is written in scientific notation. And it is. Looking at another example of adding when numbers are written in scientific notation, again, I must create the same power of 10 by moving the decimal to the left or to the right in order to match the exponent. I'm going to take the 4 and rewrite it so that I have a power of 10 raised to the 8th power. I'll move the decimal 4 places to the left. 1, 2, 3, 4. By moving the decimal 4 places to the left, I decrease the size of the coefficient, therefore increasing the size of the exponent. Now that I have the same power of 10, I can add my two numbers together. Step 4 tells us to keep the same power of 10. Step 5 says to check to make sure our answer is in scientific notation. It is. Let's move ahead to look at an example of subtracting with numbers in scientific notation. The steps will be the same as when we were adding. I want to create a common exponent or create the same power of 10 by moving the decimal left or right to match the exponent. I'm going to move the decimal for 7.1 2 places to the left to create 10 to the 9th. Now that my two numbers have the same power of 10, I can take 5.92 and subtract 0.071. Again, I will keep the same power of 10 and then check to see if my number is written in scientific notation. I hope you have enjoyed this lesson on how to work problems involving operations in scientific notation. Have a great evening.